Hello and welcome to this webinar, Keep It Simple Stupid, MES, Why Modern Manufacturers Are Choosing Modular MES with Real Shop Floor Control. This event, brought to you by Assembly, is sponsored by Pico. I'm your moderator, Austin Weber, Senior Editor of Assembly Magazine. Today's presenters are Brian Bao, Chief Operating Officer at Pico, and Edoardo Colasante, Director of Engineering at Kolver North America. Don't forget to submit questions, and later in the program, our presenters will address as many as possible. Today's event is also being recorded and archived at www.assemblymag.com. And now, I'm excited to turn it over to today's presenters, Brian and Edoardo.
Thanks, Austin. Appreciate it, and appreciate the Assembly Magazine for hosting us today. Welcome, everybody, to our weekly webinar series. I'm excited to be joined by Edoardo today from Kolver. Edoardo.
Hello, everyone. I'm Edoardo Colasante. I'm Director of Engineering at Kolver North America, and I'm glad to be joining Brian and everyone for this webinar.
Yeah, we appreciate everybody coming along. Today's idea really was a follow-up to a few questions some folks had in previous webinars about what the kind of direct theme is between the way MESs are working nowadays and connecting to the tools and actually collecting the data. So kind of a modern take on where MES needs to go. We appreciate y'all giving us some feedback. We have a pre-webinar poll that we asked a couple questions, and y'all gave some feedback on where you're at. The first was, where are you at in your MES journey? This echoes what we see in industry pretty quickly, is a lot of people are just kind of planning, looking what the MES phase should be. Some have legacy MES-like systems that they're using. A lot of people are on paper and Excel. And then about a quarter of the industry is taking a big step towards the digital journey and moving along. And as part of that, it's really interesting to see the Kolver side of this is what data export and collection do you require as part of your process. What do you think about that, Edoardo?
Yeah, this is what kind of lines up with my experience in the field. We see that a lot of customers want or wish that they had a data collection, but they don't have. I see a higher percentage of attendees that are not sure whether they are collecting and exporting data or whether they need it more than I expected. But we'll be showing you what are the benefits of collecting some of this data and how it's easier than you might think it is.
Yeah, that's the key part of it. And being an old lean guy, trying to get data has always been part of the challenge of understanding where to go do some of your continuous improvement activities. And a lot of people collect data and don't know where it goes, and a lot of people don't know to collect some data so that they have it later on. So it's really interesting. I'm excited to kind of hear where you take it with the connected torque tools. So let's helicopter up a little bit and talk a little bit about why we're talking about the KISS method to MES. In my experience, and part of why I joined Pico, is a lot of legacy MES were pretty epic to deploy. They're high costs, take a long time. I remember my first MES I deployed in 2009, which is a long time ago for some of you. And I don't know that we ever got it right. We ended up rolling off to another system 4 or 5 years later. And there was a lot of confusion. What we got there is bloat. So what we're proposing for a lot of folks is to try and keep it modular, try and keep it simple. We walk around with phones in our hands that have apps on them to do the specific tasks we're trying to do, and some of that can be integrated across. Think the Apple Health and Fitness, that set of apps, kind of things like that. And so when you're looking at modular systems, it's don't try and boil the ocean, in my opinion. I don't know. Does any of this resonate with you, Edoardo?
Yeah, definitely. I've seen customers with really impressive called legacy MES systems, but then when it came to actually deploy some new features, they either didn't know where to start or they couldn't get the resources from whichever large company they worked for or with.
Yeah, we went on one sales call 6 months ago, and this company had just bought a very large MES, doing a great job of creating dashboards, and they'd also bought a bunch of digital tools. And so they had data in the dashboards and they had data in the tools, and what they forgot was the middle module of how to get the data from the shop floor to the IT system. And that's what we're kind of talking about here. Is it's quite important that your systems start linking up so that you have to create a digital thread across your shop floor as opposed to doing things in splendid isolation on that. We wanted to jump over into a poll quick, get some feedback from everybody who's joined us today. Which MES capability would you find brings the most immediate value to your shop floor? Standardizing the work through the worker guidance, enabling traceability through data collection, error proofing through IoT devices, or integrating with your wider systems. As we kind of pop in these answers, we would love to hear back from you so we can kind of guide the conversation that's coming along. I see lots of people coming back in there. Edoardo, which one do you think would be an interesting one? I bet I know the bias on this one, actually.
I think, well, error proofing the assembly process is one that I'm always a fan of, and actually our smart torque tools have a lot of that type of functionality built in because a lot of it originated, Kolver's a 35-year-old company. A lot of this functionality originated well before MES systems were even a thing. But that and traceability from me from Kolver's perspective.
Nice. Yeah, that makes sense for where this conversation is going. Let's jump over to see what some of the poll results are coming in, and we've got a few more folks that are voting here. But just wanted to kind of show you where we're seeing, and it, particularly given the theme of this webinar, makes a lot of sense that we're focusing on that connectivity of data to the shop floor, and then enabling the operators to kind of error-proof their processes through integrated IoT type tools. Thus, why we have Edoardo here to talk us through probably one of the more prevalent tools in error-proofing assembly operations. It's also intrigued to understand some of the folks talking back to their ERP and why they think that's the most important. I think depending on your job function, that probably is quite important to get the data back from the shop floor. Had a really interesting debate the other day, actually, with an ERP provider offline, and they thought the ERP was most important, and I'm obviously pushing on the MES, but across it's getting that full data thread so you can enable everybody that's involved in the manufacturing side of stuff. So it's quite interesting. Before we hand over to Edoardo to go deep on kind of connecting the tools to the MES, I just really wanted to repaint the picture of how we see this modular system working. If you start with the data that's coming from the operator, what is in their hands, making sure that whether it's a simple scanner or a simple I/O switch all the way up to PLCs and torque-controlled devices, is really giving them the feedback, the two-way communication. Had a high schooler describe it once as gamifying manufacturing. Quite love that idea. Also then integrating with some of the other devices and shop floor specific software that's coming along, whether it's your SCADA or some of your PLM controllers, things that are monitoring machines. So really pulling that data, not only giving process data, but giving product data across that theme, and then rolling that back out to some of the wider business capabilities. So whether that's your ERP, your WMS, your MRP, things like that, giving those data the actual fundamental pieces of information of what's being produced, how long it's taking to produce it, so that they can go off and do some more advanced analytics off of it. And then enabling the whole ecosystem that comes along with it. So understanding the resellers, the consultants, understanding some of the NGOs that engage in the space to help people move along. That's what we consider a modular shop floor ecosystem, is using some of the best solutions for each and helping them interact with each other. With that very high level description of modular MES description, I want to hand over to Edoardo here, who can take it a little bit deeper on how MES ties into a really important part of the discrete assembly tooling.
Thank you, Brian. So as from the perspective of Kolver, as a torque tool manufacturer, we really see two main benefits to a modular MES system approach as opposed to a legacy monolith MES. And number one is how easy it is to connect our smart torque tools to the modular MES system. So in this case, we're here with Pico. I think they're one of the prime examples of a modular MES system. So the Kolver smart torque screwdrivers are plug and play with Pico. But it's not just that. It's even if Kolver were to come out with a brand new tool in the near future, it would either plug and play into Pico MES, or Pico's team would be able to make that integration happen really, really quickly. And likewise, if say you have some other type of device like a smart weighing scale or something like that, it's either going to be plug and play already integrated into Pico modular MES system, or it would be easy for them to make that integration happen. And I'm emphasizing this because I've been at customer sites before where they have, like I was mentioning earlier, like a nice in-house MES. We're talking very large companies that invested internal resources into building out their own MES system just the way they want it. But then I'm working with the manufacturer engineer that's trying to implement a smart tool tools into their line, and they need to integrate it into their in-house MES. And of course, the manufacturing engineer isn't the one that has the expertise to make that modification or customization into the MES system. And so they couldn't, like, they asked for the resources from the internal, IT and software team, and they just couldn't get them, or, they were too tied up, and they said, okay, maybe in 2 months we can get to this. And so they have this smart tool tool, but just the very last step of connecting it to the MES, as easy as that could be, they couldn't get the resources to make it happen. And the second big benefit that I see for the users is that you only pay and use what you need. So if you need access to a visual work instruction system that connects live to the torque tool for like instant feedback to the operator, you can get that module. If you want just data collection for every single screw that you do, you can just get and use that single module. So you can sort of build and match the modules that are actually required by you. You don't have to buy the whole thing. So speaking of torque data, what kind of torque data can you collect from a smart torque tool like Kolver? So for every single screw that your operators are putting into your product to assemble them, you will get data such as whether it's a good or bad screw within the parameters that your engineers have programmed into the torque controller. You will get the value for the actual torque that the tool hit compared to the target, as well as rotational angle and a whole bunch of other timing program parameters. You can get the full torque versus angle trace. We can go over into a little bit more detail later about why that can be useful, especially in a troubleshooting situation. And of course, you get the timestamp, so the time at which every screw was completed, which is also an interesting data point for, say, process optimization. But with all that said, let's jump into the poll question. So how would you primarily benefit from collecting torque data in a factory system? So it's compliance with customer requirements, or greater accessibility to shop floor data, real-time tool feedback to drive work instructions, process validation, or wait, you can collect torque data from a torque controller? So I'll give everybody a minute or so to answer those questions. Brian, what would you answer? Have you ever been in a factory floor where they're assembling torque data? How do you think they could most benefit?
For me, it's I come out of aerospace, so the compliance across the top is a fundamental piece through almost any factory that I've run. Understanding that the bolts have been tightened down correctly and not over tightened, which is something I learned very early in my career, that's quite a possible and dangerous thing, because we were tightening fasteners around carbon fiber material, which you crack it if you type it, if you push it down too fast. But a lot of it, for me, just generic process validation is a beautiful place to start, because when you start thinking about lean capabilities, knowing what's right and what's wrong and cutting through some of that signal and noise kind of stuff is really important too. So yeah, I like this set of questions.
Okay, great. Yeah, thanks for that feedback. Let's jump into the results and see what our audience thinks. So okay, it looks like the big winner is process validation. So making sure that what your engineers intend your operators to do is actually what the operators are doing. And I'm saying operators, by no means trying to put the fault in the operators if there's some issue in the process. Then we have greater accessibility to shop floor data for further analysis. This one actually resonates personally with me. In my previous job, I was a process engineer in a chemical plant, and my managers, they were always asking for data analysis or data-driven process optimization, or where should we focus our resources to improve our processes. And I can tell you, fishing data out of machines was always one of the steps that took the longest time. So if in that life I had something like a modular MES where I can just go and browse for all the data really easily, that would have been really useful. And then we have compliance with customer requirements coming up on third place. This is actually something I've seen with some of our customers too. It's not my favorite answer, but if you're a contract manufacturer and your customer is asking for torque data, and you may not really care for it, but you just want to check that box, having an MES system that can collect data is definitely what you're going to need. And then finally, someone in the audience answer, wait, you can collect data from your controller? The answer is yes. Kolver is one of the leading manufacturers of smart torque controllers that collect the data for every single fastener that you do. We have programmable tools so you can set and achieve exactly the torque that you need for every single fastener that you need to install. But with that said, I'm going to do a live demo of how to connect a torque controller to the data collection module of Pico MES. So I'm going to go into screen sharing mode. And so this is the homepage of the Pico data collection module. So I'm in the devices screen, and I'm going to go ahead and add a device, or rather a hub, which is a torque controller. So I click on add a device. As you can see here, we have a list of many different types and shapes and colors of torque controllers. So there are many different brands of smart torque screwdrivers, and all of the ones you see are already pre-integrated into Pico, and they are plug and play. But not all of them are created equal. Some of them are more beautiful than others, like this Kolver K-Deucer. And so this is the one that we're going to add. So I click next. So I can enter a device name. I will just shamelessly call this best in class torque controller. You can optionally give it a serial number, a location. Maybe I'll say this is for my home office. But this could be, I don't know, plant building A, plant building C, if you have a multi-site building. The IP address, this is the most important sort of field, because it tells Pico MES where to go and find that controller in the network. So 192.168.5.14, that's the one for the controller I'm adding now. And then I'm just going to enable this setting, enable torque traces. It just tells Pico MES that I want the torque graph to be collected for every single screw. So I click on add. now created what is called the hub, which is our torque controller. I still need to add a device that represents my torque tool. So I'm going to click again, add a device. This time I'll use a shortcut. I'll type KDS here in the search box because the Kolver transducer screwdrivers are called, the models are called KDS. So I'm going to add an inline tool. Again, I click next here. Device name, I'll just creatively call this Kolver.com. So assign hub. I will assign it to the hub that I just created. Here you can see a list of hubs. These are some of the other ones that I had created previously. Assign station. So offline, I created an office station. So this represents like a work cell. Imagine in your factory you have a bunch of stations, or maybe a line or a particular section in a line. You would create a station that represents that, so you can better categorize all the data that comes in. And then we'll skip these optional fields. So I'll click add. Now, every time you make a sort of a configuration change in this Pico MES software, you have to commit and approve the changes. This provides a nice like audit log of every change that was made to the configuration of the software. And in case you do something that breaks maybe some functionality, you can always revert back. So I'm going to select the changes that I made, which are listed in more detail here. Assign new device, Kolver.com. So just going to click commit here, and then I'll go over to the approve. Again, there is a commit ID, and I'll just click submit. And by the way, I'm using a user account within this system that has permission to actually make and approve changes, but you could just as well create a user that is view only, that they can only view data. So now if I go over to the data tab, this is where I see all the data that our system has collected over time. I'm in the Pacific time zone, so 10:30 was about almost an hour ago now, but I'm going to do a rundown live here in my torque bench. And now we should see that data come up shortly. And this is the magic of this system. I just did 2 tightenings. So it's 11:22 a.m. here from where I'm presenting. We'll see the device name. If you remember, I called it Kolver.com. The serial number of the tool, that's actually gathered live from the torque controller. So it's automatically imported. If I were to plug in a different torque screwdriver, its own serial number would show up here. I can see the office station and some other fields. Serial number here would be something like if I had to scan a barcode to associate with that result. And we can see the torque value, the angle, so on and so forth. And then the fun part is the trace. So I can see the actual torque versus angle graph for the entire round down for every single screw that I do. And so maybe this took more than a couple of minutes, but as you saw, it was really quick and easy. And you can connect to as many torque controllers that you have. So if you have 2, 10, or 100, you can connect to all of them and see that data pop up in real time. So we'll have some time for Q&A at the end. I'm gonna hand it off to Brian for a couple of concluding slides.
Appreciate it, Edoardo, and you did a fantastic job. And it's still one of the reasons I like working with Kolver the most is I think you all still have the record for how fast I set up a tool on my internal workstation here too. So out of the box to up and running, I was there within a couple minutes getting everything programmed. So well done to y'all for the simplicity of your own in-controller design. Makes it much easier on both sides of that story. And we start talking about the modular MES that Edoardo just took us through, and what we're talking about, the plug and play and the nature of transferring data from one system to another. we've come up with just a simple example of how those Legos kind of come together. You put some work instructions, which is actually the connected worker philosophy. So giving the operator something to work with, something that actually guides them through. And that can be either simple static slides that moves past fast or detailed slides that they kind of work their way through. Collecting the torque data that we just went through, connecting dashboards, connecting other IoT devices like smart cameras, and then providing all that data back up to the top level ERP and other MOM type systems. There's 1,000 iterations of this and probably more than that. But the idea here is, how do you succinctly put all those devices together to work for you and create your digital path, of which will, to be fair, wend its way left and right and up and down a few times as you kind of figure out the best operational strategy. So again, appreciate Edoardo walking us through that and that connected tool library with him. From there, just going to kind of wrap it up. As always, feel free to reach out to Pico. We have free work instructions. You can jump on and get a cloud version of our work instructions anytime. So you can start that digital journey. It's where a lot of our customers see the first step is coming into that. And then when you start talking about connecting to the tools, you reach out to us, and we have a few different packages that you can engage with through with your tools. Also want to point out, we got another webinar coming up here in the next month or so called SCADA MES integration. So this is a little bit more of a detailed look at how you do some of the more sophisticated manufacturing tools on a semi and automated line. So please feel free to join us or reach us out to book a demo. Also, feel free to reach out to Kolver. Edoardo is always looking for good contacts and good stories. So feel free to click on any of those links and come find us. With that, I'd love to hand it back to Austin for some questions.
Okay, well, thank you, gentlemen, for a great presentation. Before Brian and Edoardo address some questions that have been submitted throughout the presentation, I wanted to remind you that we love your feedback on this webinar, so please fill out the survey to help us prepare future programs. And now for our first question. I like this modular concept, but does that mean I need to rip out and replace my existing system? We'll start with you, Brian.
It's a great question. And a lot of people, when they start thinking about their tech stack, is what do I got and what do I bolt on and what do I get rid of? The answer is it depends. But on a simple view of things, I would say no. Find things that work with what you have if they have the ability to talk to other systems. For a number of our customers, we do the shop floor integration and then provide that information up to a larger existing legacy MES for them to run their dashboards from. Depends on what your tech stack looks like, but I would say no, I wouldn't go throw everything out. I would say figure out how to put those things you already have into their modules and then get the things to help bolster those up.
Okay. Edoardo, here's a question for you. Does Kolver integrate with any other MES or digital guidance systems?
Good question. Thank you. So yes, the Kolver KDucer line, which is the one I was sort of working with through this webinar, our smart torque controller, does integrate with any other MES that supports what is called the torque tool open protocol. And then we also have an open source integration library that some of our customers with an in-house built MES have used to easily connect the torque tool and easily make that integration. So short answer is yes.
Okay, I think we have time for one other quick question. How does hardware integration with Pico compare to integrating with a legacy MES system? Brian?
So from our point of view, and we add new devices every week, a couple, 3, 4, 5, 6 devices every week, depending on what the customer requests and what we see new in industry. We've got over 300 different tool families already pre-integrated. What that effectively does is minimizes the need for a controls engineer on the other side. So now you don't have to go in for every new toy that you go buy for your folks on the shop floor. You plug it in and walk through a similar process. And we feel a lot of times a lighter weight process for simpler devices than as what Edoardo just walked through. Whereas in a legacy system, what Edoardo just did is just the surface level. You'd actually have to go into the background, point your systems to all the different IPs, actually code in some of that capability, and then come up with your own middleware to actually pull that to whatever the legacy system is.
Okay, thanks, Brian. That's all the time we have today for questions, but please join me in thanking Brian Bao and Edoardo Colasante for their presentation, as well as our sponsor, Pico. If you have any additional questions or comments, don't hesitate to click the Email Us button on the console. And please visit www.assemblymag.com/webinars for the archive of this presentation, as well as information about all of our upcoming events. We appreciate your time and hope you have found this webinar to be a valuable experience.